Hello, hello, hello. Advent of Code Day 2 is right around the corner. I am ready to tackle it. Sorry, switching windows. There we go. So, yeah, 30 seconds away. Got my whiteboard ready. Got my code ready. My empty input file ready. Quokka is running. Output is visible. Yesterday was a pretty good one. Nice starter to get us, well, started. Looking forward to today. There we go. I clicked it. I'm clicking it again. Did my internet die? Why? I refresh page. I click it again. I middle tab. Okay. Um. Hey, internet. You wanna do a cool thing for me? Some horrible timing. No, no, it's not internet. It's them. Oh no. I'm gonna go look at the new cousin. This site's working. Oh no. This does happen from time to time. I forget what's the. Hmm. Yeah, their site just completely died. Ooh, it's unfortunate. Let me do a quick check on this. Make sure I am not the problem. Okay, figure it out faster. Jeez. Oh no. I can imagine the panic they are doing through right now. Don't need more tools. Okay. Boom. Okay, we're in. Great recovery there. Give me data. I do thing with your data. Two reports are safe. Okay, these look like rows. So two reports are safe. What determines a safe row? Levels are all decreasing by one or two. Okay, so let's go through each of them, check the differences. If the differences, got it, got it, got it. I'm going, ooh, okay, please have that working by the time I'm done. Let's do this. Const, let safe equal 0 for const line of data that's split. I can imagine part two being you're also doing verticality, but let's do this. Const nums equals line dot split. What are we doing? Spaces, and then map each of those to a number. And then just if the diffs are consistently one or two. Okay, so for const, well, for let I equals 0, I less than nums dot length. Don't go to the last one though. I have 1, I plus plus. If math.abs nums I not that many braces minus nums I plus 1 less than or equal to, or if it's greater than 2, basically is what we're saying. And then we'll say bad, or what is this? Safe equals false. So we'll start off, let's safe equals true. There we go. If safe count plus plus, we'll update this to safe count. Then we'll return the safe count. 7 is not equal to 2. Okay, that didn't do the thing. It didn't do the thing at all. I guess I want to look at this. This is what I expect. I I'm doing something different iteratively. Nums, yeah, these are all valid except for that last one. Hey there. Put me a dot trim on you. 76421. Let me do a safe check. They're all safe. Y'all can't be safe. I say you're not safe right here because this here. Y'all do not have a difference of 1. Hey! Someone misplaced a +1. Okay, it's working. Now, where's my data? Right, I couldn't get it. Please be here now. Big thanks. Drop that extra 1. Paste it. 76. Okay. Now, hopefully it's not off by 1. I'm paranoid though, so let's do data equals data dot trim. Okay, still 76. I'm pretty confident that's it then. Oh, ooh, I'm really sorry for you. Terrifying. I don't know what to do here. 76 is my answer. I'll try to be considerate. Not hit the submit button 50 times in a row, but 76 is my answer. Ooh, it's not the right answer, apparently. Okay. How many reports are safe? Because they're all... Oh, 1, 2, or 3? Well, it helps if I would read, am I right? So if it's greater than 3, then you're bad. Hold on. At least 1, at most 3. So my 1, 2, or 3. Okay, I'm curious of how mine failed. Yeah, stop looking at this one. Oh, so I said one of the middle ones was safe. Well, I'm a fool. The heck? 1, 2, 3, 4. 4. So I said this one was safe. Increase of 2, decrease of 1, increase of 2, increase of 1. 1, 3 is increasing, but something is decreasing. It's directionality. All the levels are decreasing by 1 or 2. Okay. Let dir equals null. If no dir equals nums I greater than nums I plus 1. Ascending DESC, ascending or descending, there we go. And then if there's no dir otherwise, else, if, so basically if the direction equals ascending, don't know how to spell abbreviation, and nope, come on, and it's not doing the right way, which is this way. Safe equals false, break, else if basically the opposite. I feel like I might need to do some stuff with greater than or equal to, so now I'm just doing greater than or less than. Okay, let's see what we got here. Failure. So we do need to do the 3. Now we're doing it in the wrong couch. We're just saying the second to the last one is safe. Neither increase or decrease. Boy, we're picky. Or okay, fiddled with it 17 different ways. Bigger number. Dang it. Try not to be spammy, but okay, we got it. Part 2. Engineers are surprised by low level. Tolerate a single bad level. Most of the above reports are now safe. Wait a minute, what? Wait, what? What are you doing? Are you moving a column? Oh, you're removing a column. Okay. Okay, same input. This is not what I expected. Now, 4 reports are safe from removing arbitrary column. I have to check which arbitrary column, though. Basically, I have to detect which ones make it unsafe or which one makes it unsafe. Interesting. Without removing any level, safe. Removing the second level 3. Okay, so basically I go through each one and I'm like, hey, which one of the levels do you need removed to be safe? Interesting. And what is my input looking like? Honestly, not that bad. So basically just going through it and being like, hey, let me remove you, test for safety. So let me break this. I feel like breaking it a little bit, but I think I can survive as is. So, would be safe with what column? It is column removed, right? Yeah, number array, and then I just return the one. Wait a minute. It just says removing a level. I don't have to find the best level to remove. Okay, great. I just need to be like, hey, you're off by 1. Safe would be safe by removing a level. And then we're just going to go for L0, L less than nums.length, L plus plus, plus plus. New nums equals nums, and then just get rid of it. Nums splice L1, say goodbye. Now you have new nums. You can rerun your safety logic. Boom, your safety logic. Run on new nums. Okay. And then it's if safe, return true. Not transpile module. We're not writing Babel around here. So we do that, and we're like, hey, if you're safe, or you would be safe by removing a level, a little computationally expensive, but I see it working. 4 is not equal to 2. Did I just change? I was like, hey, why are you broken? True is not equal to 4. Hey, what are you doing? What why are you returning a true? What's this code doing here? Oh, I never did the thing. Solve 2 is not defined. I'm goofing. That's a number. I highly doubt this is it, though. Definitely made a mistake somewhere. Nope, I got it. Boom. Okay. We knocked out day 2. Little hiccups with this site, but they got it back up in a jiffy. So, we got some code. It worked. Let me drop these, walk through the challenge, walk through my code, walk through a refactor, do not discard, and then walk through the refactored solution. I know all of the things. There we go. 0, 2. Boom. Okay, so we have it. Let me see. Do what I'd like to do. So, what I'm gonna take a short break, then we'll walk through the challenge and the other side. See you on the other side. Welcome on back. Let's walk through the challenge they gave us. So, we have the part one thing. The first thing I immediately saw was I saw a grid and I was like, okay, great, we might have to do some stuff with, like, I don't know, verticality, horizontally, maybe some math or maybe an algorithm pathfinding. And then I saw that each line was effectively a sub input. It's like, sure, we had a big problem, but it's made out of how many rows there are, smaller problems. So that made me a lot more confident. Then I immediately knew I needed to parse it in that way. So that's why I did parse it in that way. And then I basically wrote a function in line, not as a function, but I wrote a function to do the small problem and with its results, which is basically just count up how many of these were safe, surface them up. Second one, same thing. I had predicted they might be, oh, is it a safe in the verticality, like 719181? Is that a safe thing? It didn't go that way. It's day two, of course, so that's why it didn't get that more complex. But thankfully, it was just an addition to, hey, do an extra thing to your sub input and report more results. So that's how I kind of approached it. problem solving wise, as for the actual problem, so knowing that each of these were a different input, they don't need to be considered as a whole. They can be considered in isolation. That's exactly what we did. Now, what they're asking us to do, is to determine if a level is safe. And they defined that. First, they defined what. Okay, so they define each line as a report. And they need to determine if the report is safe. Where each of the numbers is a level. Which I'm guessing is an elevation thing. Yeah, they can differ by that much. So some form of elevation thing. So going from 7 to 6, it's a valid change. Going from 6 to 4, still valid because it's less than 3. 4 to 2, the difference is 2. It's valid. 2 to 1, completely valid. So that means the entire report is now safe. As opposed to this one, where we have an increase of 1, still safe, but then we have an increase of like 5. That immediately makes this an unsafe transition, which makes the entire report unsafe. Then we go for the second one, from 9 to 7, an increase of 2, but then from 7 to 6, this is not an increase of 1, 2, or 3, this is a decrease, which according to the rules, you can only be going increasing or decreasing. You can't change your mind and decide to go increase then decrease. So that makes this an unsafe transition, I guess, to try to fit in the story, which makes the entire report false or unsafe. So let me, put green there, red there. Nope. Oh yeah, that one is right because it's too big. Bad there. And go from 1 to 3, it's an increase of 2. 3 to 2, it's a decrease. You failed. When we go from 8 to 6, it's a decrease of 2. 6 to 4, decrease of 2. 4 to 4, it's a decrease of 0, which is not allowed. It needs to be 1, 2, or 3. I'll put out exactly where the things fail is. Nah, they're all failing us between these two pairs. That's a nice example. And then this one succeeds because it is 1 to 3 is an increase of 2, 3 to 6 is an increase of 3, 6 to 7 is an increase of 1, and 7 to 2 to 9 is an increase of 2. So this one is a valid. Which means we have a total of 2 valid, and we return 2, because that's how many are safe and valid. Part 2 of this is them saying, hey, imagine you can remove any floor. Say you remove that floor. Is it now valid? Now, that's probably a more efficient way of what I did, but it was basically just looking at it and being like, hey, the thing that made you invalid. Oops. So if we look at the invalid ones, let's just bring them straight across. Right. So the way I approached it was I was just like, let me remove every single one at some point. So it's basically just taking a cross and just being like, okay, if you didn't have this floor, would this report be valid? No? Okay, what if you didn't have this one? Would y'all be valid? Would y'all be? So to run through the first example, let's see. If you didn't have this one, you went 2 to 7. No, you wouldn't be valid. What if you had this one? You went from 1 to 7. No, you wouldn't be valid. Okay, what if you didn't have this one? You went from 2 to 8. No, you wouldn't be valid. What if you had this one? You went from 2 to 7. No, you wouldn't be valid. So you can see, no matter which one I removed here, it never became a safe report. This one, if I remove this one, it goes from 7 to 6, so we're valid. Then it goes from 6 to 2, too big of a change. Can't do that. So if we remove this one, it goes from 9 to 6. That's a 3 change. But then we go from 6 to 2, that's a 4 change. Can't do that. How about here? 9 to 7, that's good. 7 to 2, that's bad. Same problem. Same problem. So there's probably some even optimizations that I'm seeing as we go through this of early terminations and all that fun stuff. Look at this one, which was invalid because of that 3 to 2. We go 3 to 2, it's a decrease of 1. Then 2 to 4, it's an increase. Can't do that. But if we do this, then it's 1 to 2, an increase of 1. 2 to 4, an increase of 2. 4 to 5, an increase of 1. So if we remove just that level, this report becomes valid. So we did it. Now if we go through this one, 8 to 6. So if we move the 8, 6 to 4, but still got that 4 to 4 transition. I put this on the wrong one. Let me select other one. There we go. So removing this, you're not going to solve anything. But if you remove this, then it's 8 to 6 is a decrease, 6 to 4 is a decrease of 2, and 4 to 1 is a decrease of 3. So if you remove these two levels, it gets happy. And both of these become valid again. Which means we get a 2 more. But of course, these two still remain invalid. Very sad. Which goes to 1, 2, 3, 4, which was the answer. And these are the exact same ones that it said we would be safe by removing. So, that's the challenge. The raw code that does it, I believe it's relatively straightforward, but let's walk through it nonetheless. Okay. So, let's start with the first part. That's crazy, I know. So, solve one. First, we did some data trimming because I'm scared, but we didn't need to do that. Then we count up the number of ones that we have detected as safe, and we start going through every single line. This just splits our string by a new line, so we get a string that contains each line of characters. Then we decide to take that string and split it into the actual numbers. So we split by space, that gives us an array of strings containing the digits. Oh, right there you can see an array of strings containing the digits. And then we pass it to the old number constructor, which gives us the actual numbers. Then we start off with the assumption that it is safe, and with a direction of, well, we don't know what direction this is. The first one's going to let us know. And we go through every number pair by going from I0 to I, the length minus 1. This basically, if I were to grab nums, let me grab one of these, is us saying, hey, these are my numbers, and my I, let me put on the next line, is going to go from here all the way to there. So we're not going to go to the last row with our index. This is important because we're using it as this two-pointer solution, really. But our second pointer is always after the current pointer. So when our I is here, effectively our J is here. So IJ, IJ, IJ. And you can see when we get to the last the last place we want our I to be, J is actually on the last one. If we hadn't done this, then I would keep going forward to the last one, and J would be in undefined land. We don't want to go to undefined land, so not a fun place to visit. So if we do that, that's why we do that -1 to the length there so we don't go all the way to the end. Now we get the absolute difference and we check if it is greater than 3 or exactly 0. Not the cleanest bit of code here, but it's what works. So if we run through it here, diff equals 7 minus 6 equals 1, abs diff equals 1. How about that there? So since it's 1, it's good. We like it. We can move on. There we go. We can move on. It's good. And then we additionally say, hey, if we don't know what direction we're going with, if the current number is greater than the next number, that means, like from an elevation wise, we're here and the other number is here. Well, that means we're going down, aren't we? But if we are here, the other number is here, well, that means we're going up. So that's visually the way I represent that. Use a turn there to determine which direction we're going. If we don't know what direction we're going, figure out what direction we're going. Then we go to the next number. And yes, I'm going to clean this up later. So the next number is right over here. Now I'm just going to move this and put it in here, make my life easier. Yep. And where do the characters go? Characters go. There could be a negative there. Characters go right there. There we go. So now we go into the next pair where diff is a 6 minus 4 gives us 2, an absolute difference of 2. Yeah, I realize this example is never going to give us a false. So yeah, I'll go through it once more just for the difference. The directionality bit. So we already have our direction. Our direction is descending from our last run. So we look through it and we're like, okay, well, if the direction is ascending, no, it's not ascending. If it's descending, but we're actually going up right now, so our current number is smaller than our next number, which is basically the inverse of this direction check, then hey, we're going the opposite direction we said we were. We're not safe no more. You have failed. And now I'm going to run this on an actual failure one to see that outcome. I'll run it on the actual failure state. I and J. So at this point we have direction is ascending. Doesn't really matter here because the difference between 2 and 7 is, oh, is that -5, I think? 2 minus 7 equal, yeah, -5, which turns into an absolute difference of 5, but that is greater than 3. It's greater than 3, so immediately is not safe anymore, which causes us to say it's not safe and break the whole loop. And then if it's safe, we increase the count. So that's how our first function really works there. Our second one is identical, but if it's not safe, we would try removing every level to test that safety if it can be achieved, which is by just taking the array and saying, get rid of this one, or this one, or this one. So if I were to, again, go with our problematic here, so from this one, we would try every iteration of it without a number. So I think I've made enough. So we would try without the 1, without the 2, without the 7, without the 8, and without the 9. So we would try all of these and we would say, hey, can this report be safe? using the exact same calculation from before. Can this report, can this report, can this report. Go that way. And we do that by determining which level to remove by just picking one. We're doing it iteratively, generating a new report, removing that one number with the old splice method, and then doing the exact same code from before. If it's being safe, saying, hey, we found one. We found a way to make it safe. So yeah, that's how my code does this. Lots of room for improvements, which we will begin now. So, honestly, I think I can break this into a single function that just has a Boolean parameter that does some stuff, but let's start where it is the ugliest. Whenever you have kind of like, it's hard to describe this, you have an operation that is returning a Boolean, but you need to flip it and then break your for loop to do that. This pattern of I'm setting my result and then I'm returning my result effectively by setting its value and then breaking. That just is begging to be turned into a function. And we won't call it nums, we'll call it levels. That'd be lore accurate. And the reason it's begging to be turned into a function is because you want to put a return statement here, but you can't because you're in a bigger function. But now, when you put it in a function of the correct size, you are free to do as you wish, which is early return. Yeah, maybe you don't want to do this. Some people test early returns. I like them. Okay, so that was basically it. This is the first optimization, making it into a cool function. And great thing about testing is refactors like this, we can see if they work live. And since we had used this function basically in triplicate, we have so much investment on our returns here. Boom. Okay, we did it. We got rid of them. They are all still working, I think. I haven't put my numbers in. Yeah, 463, 514. Let me put these in. Just so I have them. 463. This is on me. I should have done this before I committed it, but we live, we learn, we forget. There we go. Okay, so now we can properly refactor and make sure we're not breaking all our code. So, there they are. Usually this function lives down here. I'm going to move that around. And there they are. So, made it a lot simpler by taking that logic we had in triplicate, putting it into a function. Now, what's the next bit that we're seeing duplication on? It's really the processing and the counting. And so it's a lot of the core of the problem that we're doing for both. So the only difference between these is, are we willing to attempt to remove levels? So there's a lot different things I can do. I can break this effectively into a generic thing that passes to a callback of tell me if it's safe or not, and I make a custom function that does both. I can make this a generic function that takes a boolean of attempt to remove levels. Lots of options. I'm gonna go with both and we'll see what we like at the end. So panel here, attempt to remove level boolean. There we go. If safe. And then, so if it's not safe, else if attempt to remove a level and would be safe by removing a level, safe count plus plus. I think that's the logic I needed. Great thing is we'll find out when I just call this. So solve 1, shouldn't break. It hasn't. Solve 2, shouldn't break. And it hasn't. So yeah, I was able to just add a slight conditional to the core functionality at the price of a little readability, but it's not that bad to be honest. With a single deduplicated code base, it's easier for me to do some nice refactors now. Is report safe? Now let me rename this could report safe by removing level. I don't want it to be that prescriptive. Could report be safe? There we go. I like that better. So this works. The other approach which I'm going to run is solve. Here we go. I don't like naming these things. I'll call this. Is safe is a parameterized, so it's a function you pass it a little callback that says levels number to do, and you're supposed to return me a boolean. And then it's like that, and it's like that. So it's like, hey, this hasn't really done anything for us. Well, if the trick is when we call it. So we'll call it to say data, and then the first one is just, have I really typoed this entire time? There we go, fixed it. So the first one is just being like, hey, just use the built-in function. The second one is where we get a little fancy by saying levels is, nope, is report safe levels or can, what did I call it? Where'd it go? Could report be safe levels. Okay, we don't like, which one of you are returning undefined? Who has done this to me? Oh, you never return a false at the end here. There you go. Thanks, TypeScript. With a natural error. So, we just pass a custom function that returns either of these two. It depends basically on where I want the complexity. Do I want to rise the complexity to here? Or do I want to put the complexity in here? I like lifting it up, to be honest. So, we're going to do that. At the price of a little callback function, I like this. So, getting a lot cleaner. It's getting a lot more broken out into functions. Let's go further beyond. So we're using this once. Let's shove it in there. We're using this once. Let's shove it in there. Now we could go even further, because it's basically just counting how many of these are true. So the further iteration would be of this. I'll determine if I'm going further by how I like whether it looks. Use total, and then we have line total plus 1. I'll start at 0. It's not 1, it's this thing, but as a number. So as you see, everything's still green. This works. It's a little Code Warsy though. So I understand I got a little code golfing on this, so I'm not going to go to that level. I'm looking at it now and I'm like, yeah, everyone's not going to be able to get it in a glance. So for the sake of readability, I will not be doing that. Safe count, total safe. Okay, let's do total safe, sure. Just splitting hairs at this point. But I think that is readable at this point. Readable enough. So now we have that function. Let's go to our next one. Could report be safe? Now this is one that, as I was walking through it, I pointed out that there was a room for optimization. I think these are the last two functions we can squeeze out anything for our refactor on. Is report safe and could report be safe? Well, one kind of depends on the other, being a little bit fancier. Okay, so we're gonna break this into another subfunction. um, so what are we calling these individual numbers? Levels, right? Okay. Get unsafe level. Basically, the level that is trying to figure out, because technically an unsafe level is not inexistent. It's a relation. So it's like 2 is an unsafe, 7 is an unsafe, going from 7 to 2 is unsafe. So I guess my unsafe level, if I were to define it, would be the first of the pair. Get unsafe level. So yeah, we're gonna do this, and instead of returning the booleans, we're gonna return the index of the unsafe level. Who's the problem child? And if there is none, we're going to be kind of like a find method. So we're going to say find unsafe level and be like, hey, -1 if you never find anything. So this is kind of like a find index. So we do that, and now we've done that. It's like, why do we do that? It's like, don't worry about it. We're going to use this so we can optimize our could report be safe. But first, we need to make our is report safe non-duplicate, because we just did some stuff that makes them quite redundant to each other. So it's returning find unsafe level levels equals -1. If there is no unsafe level, then the report is safe. Everything is green. So we just move that logic into here, change the return signature a little bit, because we can now use it here. So we need to think for my optimization, because I went through it where I was like, hey, yeah, once like 2 and 7 are the unsafe ones. If you're out here removing 8, then like you're wasting your time, because the unsafe level's back here. So I think there would be some kind of optimization of being, hey, let's grab the unsafe level. It's gonna say it's 2. Once you're like 2 ahead of your unsafe level, just stop trying. Like, these 2 bottom ones should not be attempted. We know doing that will not make it better. In addition, speaking of, we don't know that if going to 1 will make it better. For a longer one, we might be able to assume, like, starting so early wouldn't be worth our time either. But that's the optimization I'm going for. Don't know if I'm going to land it, to be honest. So we're getting a little fancy here. Unsafe level equals find. Nope, not find first. Find unsafe level. And these are not nums, these are levels. New levels. Okay, so now we're just going to try to go to I. So we know this one is 0, 1. Plus 1 plus 1. So it's kind of a math max. N equals math dot min levels dot level length. Then it's unsafe level plus 2. If the unsafe level's at the end, though, we need a math max around this. No, we need a math min around this. Math. I love math. My best friend is math. Okay, this is a great thing about having real data to run through. We can run through it. So let's drop these two, let's drop this one, and let's try to find an example that's actually easy to go through. This one. Now let's go through the one we've been looking at. 127. Boop. Give. Boop. Boop. Okay, yeah, you can be safe. Actually, can you? You cannot be safe. I'm very sorry for your losses. But we should not try everything in the universe for you. So let's looky-loo. Hey, are you not trying? Why are you not trying? I'm on the solve one, not the solve two. Put it back. Put things back. Put things back. Went to the wrong one. There we go. Boop, boop, boop. The answer is 0. Okay, now that we're here, can we see some stuff? Yes, we can. We see unsafe level is index of 1. And we're gonna give up at 3, right? What if, look at our levels. I'm just playing the advocate here. Unsafe. What if our unsafe level was 8, so the highest it could be? Then we would go to 5. Okay, I didn't mean 8, I meant 0, 1, 2, 3. Then we would go to 5. Well, 3 plus 5 would do it. Oh, so that actually does work. Oh, it's doing the thing. This is the behavior I was expecting from the math I wanted to do. Okay, great. So it's doing it. It's doing it well. I can now use this. So, hold on. So if unsafe level is 1, let me get back over here. Yeah, let me make this a little easier for my brain. 0, 1, 2, 3, 4. So if it's 1, then I want to try 2, but not try 3. And 0, 1, 2. Yes, this is exactly what's happening. I don't want to try 3. I want to give up on these 2. Okay, I love it. So that optimization is happening. Now I like to make a scenario in which we have the beginnings are great. 4, 5, and then let's just say it goes to 9. So in this case, we need to get rid of the 9. So our removals naively would look like this. That one, rid of 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 that one. So, but naively, they look like that, but I wouldn't want. Here's a tricky thing, because the directions are set by the first one. So I don't think I'd want to start at you. I think I want to start at the friend behind you. So I'd want to consider these bottom 2, but not these top 3. So no, make it right. My effect no to these ones, which means my starting index would not be 0. It would be unsafe level -1. So it'd be 5 -1. Let's see if we can go for that. I would need to put another thing in here with this sample case. And this one can be made safe, so turn you into a 1. There we go. So unsafe level is 4. 0, 1, 2, 3, 4. That's correct. And then be -1 is where I want to start. So let's say const start equals math.max 0, unsafe level. Mm-hmm. Okay, what if is 0? 1, 2, 3. I really don't know what I expected here. It's doing the thing. Do I even need the max? Because it can't be less than 0. So I can just say the unsafe level. Because it can't be -1 in this universe. Drop all that. 4 and 5. Hmm. Yeah, we start the one behind you, and then we start at you, and then we start after you. Because we don't know if your predecessor messed you up. I mean, hey, it's a good theory. We'll know if this works really soon. Gonna put in the original stuff where we're gonna be expecting a 4. Yes, I violated all the test-driven developments by just modifying a test instead of writing a new one. Nobody will tell no one. Oh no! Now, did I typo that when I manually shoved it in there? No, it is actually wrong. Okay, so if we were to overcorrect in one of the directions. Aha, so it was the start being weird. That's okay. We still did get some optimization out of this. -1, max 0. I kept describing it, but I was like, oh, it's not a problem. This was the thing I was trying to describe. So in this case, it was 4, and I was like, okay, great, we can start at the 4. But I wanted to start before it, which is why I put the max in there. But I never put the -1. Oh, this is confusing me. I understand how I got confused because I was talking about index 4 and then it was value 4 and all that mess. But basically, if this is the problem level, I want to start trying to remove before it, which would be if this is the problem level, I want to start removing before it, but you can't go, there's nothing before it, so you have to max it to 0. Okay, I'm liking this now. The only thing I don't personally like is that I'm doing this memory splicing, but it works. Hey, Azure Empress, how's it going? Thanks for the raid. Would I be correct in assuming you were doing some advent of code? Hey there, Luna Request. I'm just doing some advent of code, doing a little bit of refactoring. Ooh, game dev, nice. I've been meaning to get into some game dev. Thinking about going down the Godot route, exploring some 2D stuff over there. Part 1 and 2 of day 2. Nice, Luna. As did I. I was just cleaning up and refactoring my solution. Any cool games? Is it games done yet? Or is it still in the ever cycle of development, right? Gotta make it perfect. Hey, MTJ artwork. Oh, a demo on stream. Nice. I'll have to check that out. Yeah. Thanks for the raid. Definitely will check that out. Even if it ain't Godot, it's all same processes under the hood, just different tools. Of course, yeah, yeah. I appreciate it. So what I was just doing, I was basically at the not the end, but I solved the problem. I did it very raw. Then I walked through my solution, walked through the challenge, have nearly refactored my solution to its perfection, but there's a little bit remaining. So it's mainly this ugly looking function here. For those who are not avid enough coding, this was a two-part challenge. For those who don't know what it is, Avid enough code is a website that releases 25 problems over the December days, kind of like an advent calendar. They come in two parts. As you solve the first one, the second one is released. You can solve it however you want. Excel spreadsheets, pen and paper, or more commonly, your favorite programming language. This one was a pretty good one. They do get more difficult, but we were given this blob of numbers, and each line represented a report that could be safe or unsafe based on some logic. We determined what that is based on their rules. Yes, there are some people who solve it in sheets, Luna. I have a coworker. I have at least one coworker who I know gets to like day 15, not all 15 days, but like up to day 15 to some problems, being able to excel it away. But yeah, she Google Sheets, Excel, powerful tools. Yeah, we have all these safe and unsafes based on a few rules. They have to be going in the same direction, and the difference must be between 1 and 3. Part 2 is, hey, you get to remove a problematic level, and if that makes it safe, congratulations, it's safe. I already walked through the basics of that, but logic was basically, hey, look at every two things, determine if it's safe. If it's not safe, it's not safe. The part 2 is you get to remove a level, and if that removal of the level makes it safe, congratulations, it is safe. Oh yeah, I think I've been doing it for 4 or 5 years. I haven't started Evan Code at the beginning, but I think all of them were the first 2 years or the first year, Luna. Yeah, that sucks. I think last year I wasn't as consistent as I wished, but I made it. So yeah, that last bit that I optimized was the could report be safe function. Very fancy function that it used to just be like, hey, let's try to remove every level and see if we get to a level of safety. But now it only removes levels around the problematic one. So the problematic level in this one is 4. So it doesn't try to remove 0, 1, 2, because those are perfectly safe levels. Don't touch the safe levels. Instead, it only removes the problematic ones, which could be the one before the unsafe level, because the predecessor could make it unsafe. Could be the unsafe level, or it could be the one following the unsafe level. So by reducing this to don't try to remove all of them, just try to remove the few of them. We optimize that. I think the only improvement left is this, but it's mainly just going to be the readability of this, not the functionality of this. Oh, yeah, Rust. I mean, the language is good to write in, and yeah, those who write in it are usually good at writing in it. So let's first thing refactoring, we identify the duplication. So let's just say const diff equals others. So we can say that to that. And let's do the easier check first. So if difference equals 0 or greater than 3, return I, which is basically saying, is this unsafe level? Get rid of it. And this is a just really weird way of saying the difference is not between 1 and 3. But it's really weird of saying it, so I don't like the way we're saying it. So let's do math abs up here. And just say, if not between the two things. So if not 1 less than or equal to diff, and diff less than or equal to 3. There we go. This might be a little weird looking, but it's a common if conditional when you write it this way, like, hey, look, if diff is in the middle of these two numbers, and then we just say not. So I like that. Then we have this directionality set up, which we do it inside the for loop. We don't need to do it inside the for loop. We could just do it outside, make it a lot cleaner. Yeah, Luna, that's the way I do it too. I just jank my way through these first just raw, and then I clean it up after the fact. I think that's what, I won't say everyone, but a lot of folks do. Boom. Okay, so we reduced the complexity and ungrossed the actual for loop itself by taking the direction calculation. Don't need to do that. Outside of it, which allows us to make it a constant. Now we are doing this a little bit. We can variabilize this even further. So current equals levels I, constant next equals levels I plus 1. Again, we're not winning any efficiency awards here, but this is going to make a quite bit readable. And that would actually make it more efficient, because less time accessing the thing. I actually pasted it, though. Boom, there we go. So the difference, if the difference is not between these two values, return I. If it's ascending and current is greater than next, bad. If it's descending and current less than next, bad. I can understand this kind of if I think about it, but we can get free readability by breaking this into a function. Function get, what do we want to call this? Difference direction. It's a horrible name, but we'll start with it. A number, B number, return A greater than B, descending, ascending. So great thing is here we can now do this. We love that. We also get free typing because this is now a constant. And now, we can go even further, but I'm not going to go there yet. So if it's ascending and get difference direction between current is next equals descending, then yeah, it's bad. Or get difference direction between current and next equals ascending, then it's bad. Yeah, we get it. But here's where we can go to the next level. What we're basically asking is if the current direction and the direction between these two don't match up. So we can just do this in one by saying if direction not equal, get difference direction between current and next. Not 2, not 1, I. Oh boy. So we can replace both of them with this single call right here. I tried to think of a better name in those 3 seconds. I could not. So we're going to live with this name. And boom, this makes it a lot readable. Now we could get a little gross here. What we can do is we can throw it in there. Doesn't that look so readable? No. I'm going to keep it as 2 separate things, even though functionally it's all good. But having this single character does make it hard to read, and adding this will make it longer to read and make that hard to detect. So, current, next, difference, current, next. Yeah, I am liking this pretty well. Yeah, I'm gonna move this up. Move this around a little. I'm gonna call this refactored. Okay, I could do something fancy with this. Let's do something fancy with this. because I'm making an array and I'm removing something from it, I could initialize it without the level I don't want to care about. So let's do that. Cross new levels equals levels.filter filter. Now we don't care about the level, we care about the index. Index not equal to level. Boom. So basically we were like, hey, give me all the levels, but then when it's the index of the one I don't want, don't give me that level. Computationally, maybe a little bit more, but we're still creating a new array in our memory. So I like it. I like it so much because it makes it a one-liner, which we can put out of all these variables. Ta-da! I'm not going to go any further than this, to be honest. Unsafe level. Oh yeah, how would you want to put this in a variable? Const start equals kaboom. Start and end. I like it. I like that a little bit better. And yeah, I think this is... So this is really just a sum call, but we're going over index, so I think this is fine, honestly. I'll move this up to one more. So I did not like the readability impact of going that far. But yeah, this feeling pretty happy with. And still passing all the tests. So with that final refactor, let's walk through the solution code one last time. And then we will call it, because I don't see a short-term visualization I could really spin off of this or anything interesting. So, well, let's put this back. I just realized about half the tests off, but nope, they're good now. Okay, so let's go through this. I'm gonna drop this and my part 2. Keep it simple. So both solve1 and solve2 end up going into a single solver function. That solver function counts up the number of items that are safe. Already walked through the lines, but for every line that gets processed, we turn it into an individual line of strings. Then we split that into an array. Then we turn that array into an array of numbers. We pass that to our super cool and custom isSafe method. Now in part 1, isSafe is report unsafe, which finds the unsafe level and says if it's -1, which is a common JavaScript way of saying does not exist, then there are no unsafe levels. Now, unsafe levels here, we start by getting the direction between them. So that is always between the first two. Hey, what direction are we going? We're going descending or ascending. Can only be 2 options. That just compares which one is greater. Based on that, returns the correct order. So 7 is greater than 6, so we are going down. 1 is less than 2, so we are going up. Then we go through every level. And again, this can be seen as a 2-pointer solution where the second pointer is the one after the current. So our main index never goes to the end. We -1 that. And the one we're comparing with is always the one after. So we have that, and then we calculate the difference, which is absoluted between the two. So 7 and 6 has a difference of 1. 1 is within this range. This is a little kind of tricky, but not too crazy syntax of saying, hey, is diff basically between these two numbers? Inclusive, because I'm using or equal syntax. And then we flip it with the not. So if it's not between these numbers, it is, we can see, until we hit that 5, in which we're not. So if we're between these numbers 1 and 3, then we're going to move on to the point where we check the direction of the current pair. And if it's wrong, or if it's different than the main direction, well, then we know that we have found the wrong level. And then if we don't find it, we return -1 because we made it through all of them. That is how the code really works. Honestly, it's a lot simpler, obviously, thanks to the refactor. And that is part 1. Part 2 is only part 2 because it provides a safety function that is 2 safety functions. So it's if the report's currently safe, you're good. But if the report isn't safe, let's check if it could be safe. Again, we're using the short circuiting of JavaScript of if this is true, this will never be called. But if this is false, then this will be called. So could report be safe? That's what gets called. We figure out what level is unsafe. So let me look at this. Levels. Something's not running. I think I've commented too many things out. Here it is. There we go. Yeah, so if we look at the levels, these are all unsafe ones, by the way. They could not be here if they were safe. And we can see the level that was found that was unsafe. So we can see for this one, level 1 was considered unsafe. Level at index 1, to be clear. So this level 2 was like, this is it. It's an unsafe level because going from 2 to 7 is an increase of 4. It's illegal. You can't do that. So this basically says this is unsafe. So let's figure out where we want to start and end. So I'm flipping these around now. So we want to start at 0 and we want to end at 3. And the way that works is that we want to start here to and end here. Well, 0, 1, 2. It's really these 3 we want to try because let's say like these 2 are the unsafe level. Removing 9 is never going to make those happy. Removing 8 is never going to make those happy. Like, they're not going to get any safer by removing an unrelated level. It just won't going to happen. So we don't even try it. We only try the ones that will potentially make it safer. Yes, there's probably a fancier way of doing some checks and stuff, but I was too lazy to do that. I figured this is enough optimization. So that's all that logic there, and then the necessary min and maxes for us to not leave the universe. Particularly this one is if our unsafe level is the 0th one, then since we want to check the one before our unsafe level, because it could be making our unsafe level unsafe, we need to do that, but that could put us in -1 territory, the undefined lands. We do not want to go to the undefined lands. Same for the end. We want to go +2 to our unsafe level, because the one after our unsafe level could be the problem, and end is exclusive, not inclusive. So we want to do +2, but then that might throw us to the undefined lands. So math.minute against levels length to keep us in the defined lands. And the rest of it is relatively straightforward. Like, this was a bit mathy. The rest is just you start at the start, you end at the end -1. I really don't like that, but it's the way we generally do in JavaScript. And then you generate all the new levels, which is the old levels, but get rid of the one that is at the index of level to remove. You check if those are safe. If so, congratulations. Your report could be safe. That's all we were looking for. Then you return true. If you were never able to find a level that you could remove to make it safe, you return false. Everything else remains the same. The custom function handles the logic. And that is it. I think I'll be committing that away. Not 21, 2. Where's my code? Where's my code? Why are there 17 billion changes here? Why is this not in my Git ignore? As you can tell, this repo is not exactly in the cleanest of states. But that was the problem. Or that was the challenge, both parts. That was my initial solution, my refactoring, and the refactored solution. I'm trying to think if there would be any fun things to do with this data or these changes. It could be made into some kind of interactive experience, a tiny game. I don't know if it'd be the funnest, because it'd be a game. It'd be that fun. Visualizing these bar charts or the line graphs could make some visualization out of this fun. But yeah, none of which I'm too passionate about. So with that, I'm going to go and see if we can find any other Advent of Code streamers to send y'all off to. There's the Advent of Code tag. Is there not a tag for this no more? I have it on, I just gotta find the thing. One moment. Unless there are any recommendations in the chat. Oh yeah, we got a few. So there's Python, there's Go, there's Rust. Oh, I didn't realize this thing keeps doing this. Okay, I think I realized what I just do that. I do to break that now. Apologies for the rainbow explosion. Me making that go full up. Hey, Rust Gang it is. Let me Advent of Code in Rust, day 2. Let me see. Mr. Dima 981 is where y'all will be headed. Please start working, Twitch. Cool. So yeah, pleasure as always. Let's go. Won't be able to stay long, but I'll be able to give them some good vibes, and at least I'll have one Rust fan, right, Luna? Pleasure as always. See you next time. Bye.
Holy shit, we got raided by Pascal too. Thank you for the raid.